Hello, and welcome to the second episode of our CNC build. We've been working on the CAD for a while. Sorry we didn't post a video. It was kind of all involved. Lots of CAD happened. Anyway, so what you can see right here on screen is the final model that we're currently working with as we begin assembly. It contains all the main parts, and we're going to try and show them all to you today. First off, Gavin's going to start by explaining the base.
Yeah, so for the base, we have all of our bars that you see here replaced with peanut bars, which you'll probably see a photo of here. And the peanut bars are made in imperial units, so it's 2 feet, and that is roughly 606 millimeters. That makes the bars that have the slides on. We mounted them right in the middle, so we have a little overshoot on both sides. Um, and we thought that having 3 bars connecting those slide bars was strong enough. So for the couplers that you saw in the base model earlier, we made 2 different types. One that has a flush side so it can run against the wall, and one for the middle that has the 2 prongs that you see now. Uh, these were made to join perpendicularly 2 different bars, very strong and kind of elegantly.
So what you're about to see is my very quick design of the leg. There's like 3 versions of this, but this ended up being the final one as it has all the holes we need. Has a version with an inset for the end stop limit switch, and generally has a big surface area for the whole machine to rest on. So yeah, pretty quick, pretty easy, simple enough. This next feature here is fairly critical. This is the motor mount for both of our Y-axis motors. As we said in the first video, we're trying to drive with a dual Y system, so we had to make sure we had the motors in the right space, at the right height, far enough back so we don't compromise our build surface, and that's what you can see here. This version we settled on is probably version like 3 or 4. Initially, we just had a rough one mocked up where it was too far forward, and then we changed it just to make sure we have the space for the lead screw and everything to fit correctly, and that's what you see here.
For our X carriage, we spent most of our time here because this is a very crucial part and it takes a lot of filament to print, so we really only had one shot at this. So we have a parallel plate type of design, and we're going to have an underpass bar, 2 of them that you'll see. Uh, we inset the slides so then they are flush against the walls for a lower profile. And as you'll see, we've made 2 different versions of this piece, but we chose the latter version, as you'll see. When we got the peanut bar, we cut them down to 600 millimeters, so we have them all standardized. And I tried to make a extension off the sides because originally I was planning for something around 700 millimeters. And you'll see it right now. It gets cut off and replaced because we found some peanut bars that were the right length. That streamlined our print, cutting down almost an hour off each of the prints, which was amazing because most of our prints were 20 hours or so. On the sides, you could see aluminum plates being put in to reinforce that really thin area where the slides are. Um, for the stepper motor, it's just a basic 4-hole mount. We put a little truss underneath it to help hold the supports.
So the next part we designed was the entire sub-assembly for the Z-axis, which is pretty critical. I wanted this to be as compact as possible and took some inspiration from stuff I saw online. Basically, you have two sliding linear rails, much smaller than the ones we were using for the X and Y, but two rails with a clamp system for the router, which you can see I just put in there. And it just slides up and down. At the bottom, I made a little nice custom end stop thing with a fitting for the limit switch and some holes for wire management. Soon in here, after I finish touching it up, you'll see I begin to add the stuff for the lead screws as we got it, and then I add in the mount for the stepper motor, which we just decided we would mount vertically. There was some uh, deciding between trying to belt drive it because the space between the two plates you can see is actually almost perfect for that. But we decided that would be a lot of extra effort, a lot of dealing with belts, a lot of stuff we did not want to really mess with. So we just decided we would mount it vertically. And yeah, that's what ended up working.
Nice.
So yeah, that was the CAD finished, and it's on to the assembly process now. Uh,
Yeah, it's been quite a while making this CAD model. It's been really a journey going through this.
Pretty fun.
Yeah, a lot of
Yeah,
time.
I think we learned a lot. It looks great in theory.
Hmm.
Hopefully it works.
Yeah, I know
But
the integration between CAD and real life is sometimes a
not the
large
most
gap.
fun. Yeah, but we'll see how this goes. We have three printers that we have, and we've already ordered a lot of the
Hmm.
materials, so we're excited to try and optimize this print process for as little pain as possible.
Yes.
But yeah, thank you guys for watching this one.
Yeah.
Sorry for the
Thanks.
later upload. The cat did take a while,
Yes.
and we'll update sooner when our assembly process is finished.